next speaker is my co-host on the Elixir Wizards podcast. He's got several open source projects, and his talk is called All Aboard the Stateful Train. Eric Oestrich, everybody.
All right, so yeah, I'm Eric Oestrich, and this is All Aboard the Stateful Train. So I'm Eric Oestrich. I'm a wizard, also a technical architect at SmartLogic. SmartLogic is a consultancy based out of Baltimore. We build custom web and mobile apps. And so this is what we're going to take a look at today. So like, what does a standard application look like? Why might you want to go stateful? What does a stateful application look like? Is stateful even better? And seeing how we can go stateful. So this is Warf, my cat. You may see him around. But yeah, so this is a standard application. It's going to use stateless HTTP. Your controllers are going to go straight to the database typically here. You're not going to leverage your own OTP, so you're just going to use what Phoenix and Ecto give you. And you can kind of think of this as MVC or Rails-like. So probably your standard, a standard application. This is Kern, my other cat. So a stateful application is still going to use stateless HTTP because that's what HTTP is. But then you're going to kind of toss in WebSockets and long-lived TCP connections. You're going to start using your own OTP supervision trees and processes, and you're going to push stuff outside of a web request. So kind of the background processes. This is Warf again. So why might you want to go stateful? So Erlang is really good at this, so let's do it, right? You can actually build in like your Redis cache or Memcache into the beam so that you don't have that extra network request, so that it's even more local. Less network means faster requests. You can build your app to be resilient outside of just your Phoenix controllers, so you can kind of withstand anything. And your websites will start to feel more alive. So that's kind of the LiveView or just doing regular WebSockets with React or Vue or whatever on the front end. And again, Erlang is really good at this. It was built to run on phone switches like 30 years ago. And phone connections are very stateful. And in order to stay alive, they have to upgrade a live running system, which is keeping a lot of state going. So let's take a look at some stateful applications that I manage or that I run. This is Xventure. Xventure is a MUD server, so this is going to be way on that stateful side over there. Before we get to what Xventure is, a MUD is a multi-user dungeon. It's an online text adventure, and you typically connect with Telnet, but we're very slowly pushing out of that into future things. And I know no one ever pays attention to these things, so if you want, you can go to midmud.com right now and start playing an Xventure instance and see what that looks like. So Xventure is a living world. Everything is always on, so it kind of has the whole world. We'll see kind of how the world is broken down in a bit, but the database is really only there for startup and then kind of saving stuff as it happens. And there's a lot of inter-process communication going on, which we'll see. So real quick, we'll take a demo. So this is what Xventure looks like out the gates. So zoom out a little bit. So you can kind of see this is we're standing in a room. So we'll have a title of the room. We'll have a little bit of a description. So the south end of the wall has a wooden door embedded in the rock wall, right? And then we can see a little map and exits. So you typically move around in MUDs as a room-based thing. So each of these rooms are a process. So we can go south. Now there's a bandit here. He's targeting me. And I can go ahead and magic missile him. And he's going to shoot back at me. I can heal myself. I can magic missile back. And all of these are doing a lot of inter-process communication. And hopefully this bandit will die. There we go. So now he's dropped a bunch of stuff into the room that we're sitting there. We can see it on the floor. We do get all. So now we have a bunch of elixirs. We can go north because the bandit respawned. And so now we can sort of see I should start healing stuff back up just kind of by being there, as is typical with games. So that's Xventure. Now we're going to take a look at Grapevine, which is the shirt I have. So Grapevine is a mud community site. It's going to sit kind of in the middle between both of these because most of the site is a standard application of being stateless, and it's just going straight to the database and back out. But there's enough other stuff in here. So the cross-game chat and the web client that we'll see is this highly stateful stuff. And you can kind of think of this as Steam for MUDs. And there's a bunch of caches as well. So let's take a look at that. So this is Grapevine. One fun fact, this is actually a LiveView right here. We're not going to see it change because I'm not on the internet. And this is a local version, but you might see that change on the main site. And this is at grapevine.house if you want to see this. And so this is a game here, so we can click play. And we can go ahead and sign in. So this is using the telnet. This is actually a telnet connection happening inside of the web server. And if this was on production, it would actually be a separate Erlang node, Beam VM. And then they would talk to each other via distributed Erlang. And so now we can start some combat spam here. Oops, if I can remember how to do this. And you just kind of see that stuff is happening, right? Text is being output, these gauges are changing. And so the really cool thing is that we can actually go ahead and just navigate away, right? We can start clicking around, looking at stuff. Let's refine that web, or the game, right? So we're back at the profile. And we can actually click play again, and it's still going on. So this is the cool stateful part of it. So there's a web channel that dies and comes back, and we reconnect. So is stateful even better? Like, do I want this? And this is Odo. So it depends, right? So there's some pros here. So we have soft real-time capabilities. This is what Erlang is built for. Your website can feel alive and feel like, I don't know, Web 3.0 or whatever we're on now. So you don't need to refresh your website in order to do things. You can reduce your database queries. Less round trips is a faster response time. So some cons. This was actually right before that first picture there. So you need to use a heavy OTP. You have to architect out what your application looks like internally, so it goes beyond what Phoenix gives you. Caches are hard. This is the famous saying of there's two hard problems in computer science: cache invalidation, naming things, and off by one errors. Right? So you're not escaping that. So that's here too. It can be harder to deploy. You might have to warm your caches on boot, which might slow the boot process down. Long-lived connections will drop when you restart if you're not doing hot code upgrades. So you kind of have to know how you're going to deal with that. With Grapevine, I actually went ahead and put in the docs for connecting to the chat socket. Like, step one, I will go down, make sure that you can handle the reconnection because this is a side project and I don't care enough to make it survive that. And if you have a clustered application, you'll need to be able to handle a rolling restart. And if you're not familiar, this is what that looks like. So this is a surge rolling restart. So we're going to start with 3 old nodes. You're going to bring in a new one, kill off an old one, bring in a new one, kill off an old one, bring in a new one, kill off an old one, and now you're just new. And kind of throughout this whole process, you have to make sure that your code is ready and able to handle the old code and the new code being able to talk to each other. Because if this is a distributed cluster, old code and new code will be connected together because of how the distributed Erlang works. So that's a thing that you have to be aware of, ready for. Might not be an issue until you get really deep into OTP, but that's a thing to be ready for. Speaking of Here Be Dragons, so other things you'll need to be ready for, the mailbox size for processes can be a big thing to deal with. As the mailbox fills up, this is the bottleneck of a single gen server, so as it fills up, it actually gets slower to process that mailbox, which then just fills up faster until it gets eventually too big that a gen server call starts failing because it's longer than 5 seconds, and then kind of blows up and then restarts and starts the problem all over again. So Erlang still got your back, but it's there. Another thing to be aware of is message passing copies data. So one of the early things I was doing with Erlang or with Xventure was load testing, and I just did it super naively and was passing around whole ectostructs between processes. And my desktop at the time had 64 gigs of RAM, and I actually ran out of it and crashed the beam because of that. So like, it's very important to know that message passing copies. And then you have your typical clustering woes, net splits, and all the things that the cap theorem brings. So let's go ahead and go stateful. This is also Mia. So you can start with your gen servers. So it's the basic building block of OTB. This is how you handle your stuff out of the HTTP process. Kind of any of your background tasks and state that you want to hang on to. You'll have your supervision trees, so watching over your gen servers to restart when they fail. One of the other things you can start to reach for as like your next step beyond that is ETS, which I think we'll see more later on in the conference. So it's the Erlang term storage, very fast reads and writes. It's built to be concurrent. The other thing that this also copies data anytime you pull out of it, so that's just something you need to be aware of as you're using it. So if we put all this together, this is Jadzia. So here's the innards of Xventure. So at the top we have our application, and then to the side over here we have the Phoenix application with HTTP and a WebSocket. We have a telnet listener, and then we have the world over there. So the world is broken up into a bunch of zones. So if you've ever played like EverQuest or World of Warcraft or any kind of MMO, they have like the world is broken into zones. So like you could say like the zone is like this area of the Alamo Stakeout or at the Alamo Drafthouse, kind of around here. And so like each room down here, and some of this is cut off, I guess, but there we go. So each room over here would be like there's one room for like maybe the down here part of the theater, and then you could go up to this. A different room might be the top half of the theater. And so that's how you can kind of think of that. And then there's NPCs that are I just recut off, which are the characters of the world that are non-player characters. That's what NPC stands for. So when you connect into the game, you're going to have a session process, which is going to link very heavily with however you connected. So they're going to have a very strong connection to each other, shuttling data back and forth. And then your session is also going to join into the room, which will then have a very strong message passing back and forth. And same with NPCs over there. So here's how the connecting to the world works. So we have our client. So that the client would be you or the browser or a MUD client. And then we have, so in this case, we'll use a MUD client because we're connecting via telnet. And then we have like the world node and then our database over there. And one thing to pay attention to as we're seeing more of these is the database column and how little it gets used. Right, so our client's going to go ahead and connect to telnet, and then it prompts you to add for a login. Some games do ask for their password over telnet, so be aware of that. So we're going to go ahead and authenticate. That's going to then, the telnet connection will verify your credentials onto the database, and then it'll load your user out. You're going to have your session process that will then enter the world. So it's going to send a message to the room that you're joining, and then it's going to do a call to say, hey, what does that room currently look like? So that's that red back and forth, and then it's going to display the room and right back out to the client. And then your client's going to say, I want to move north. So then you go ahead and leave the old room, you enter the new room, do another call to see what the state looks like and display it back. And so none of that past signing in actually touches the database. It's all just process communication and working on the state that's already in the memory in the gen servers. The one thing that Xventure does use, kind of the standard application, is there's a web admin that will update the skills and rooms and everything here. So if you go to edit a skill, you'll click the edit button. That'll load the skill out of the database and display the page back to you. You'll type in whatever you want, click save. That'll then go to the controller. That'll save it to the database, and then display out. And kind of in between that, there's a PG notification, Postgres notification system going on there. That there's a cache process that is listening and has subscribed to these to the Postgres has a pub sub internally, which you can do. So it's listening for updates to this table. It gets the broadcast, a publish that this thing changed. It's then going to go ahead and load the skill back out and updates its internal cache. And I went with this route because each node will have its own cache listener. So you can update it through a single controller like you just update it through the controller, and then that'll push it out across the cluster. So it's kind of like, I don't know, poor man's amnesia, I guess. So this is how you can how you use a skill, right? So we have our player, the session process, our NPC, we have a skills cache, and then that very lonely database line over there. So we're going to go ahead and use Magic Missile, which is going to then look up the skill in the skill cache. It's going to calculate any effects that might happen. So like it's going to do 10 damage, and I also have this buff on me, so it's going to do 12 now. And then so it calculates that, sends it to the NPC. The NPC will then go ahead and apply its own effects. So maybe it's got armor of 4, so now it's only going to do 8 damage. And then it's going to respond back out and display it through to the player. So it's going to say, you did 8 damage to the bandit. And this is how the Grapevine web client works. So we have our browser, the main node, the telnet node, and then the game. So your browser is going to go ahead and connect to the main node, which will start a WebSocket, which will then start a telnet session on the telnet node, which will connect to the game, get game data, and shoot it all the way back to your browser. So now we'll go ahead and close the tab or navigate away or anything that'll kill the WebSocket. Right? The game is still connected and is sending data to the telnet node. Your browser then goes back to the play page, reconnects, starts a WebSocket, it then reconnects to the same process that was the game already and kind of takes it over, and then your game data flows all the way through again. So that's how that works. So to wrap up, Elixir gives you the tools to build stateful applications with ease. Right? RAM and CPUs are cheap, so you might as well use them. An easy way to get started with all this is to use LiveView. So that's you can write your super stateful applications in Elixir and not need to worry about the JavaScript stuff to make a website feel alive. Right? And again, I just want to repeat, you might not need this. Like if you're just building a CRM or like e-commerce site, like you probably don't need all this fancy stuff. Just make a CRUD app and be done with it. And also, just want to show off. This is Xventure is kind of getting a rewrite. So this is Kalevala, which is the new rewrite for that. And I just got a logo, so I wanted to show everyone. Yeah. So this is all of this is open source. There's Xventure. There's Kalevala. Grapevine is open source as well. Also, Warf has a Twitter and a website, so you can go to war.fi to see a random picture of him. So please do that. And he also tweets out every 4 hours, so there you go. And if you're interested in text games, I have a podcast called Titans of Text, where we interview people around the text gaming community, whether it's interactive fiction or a MUDs. So you can see that. And I'm also part of the Elixir Wizards. And then we're also, Smart Logic is doing, we're starting to think about doing a pop-up conf. So this is 2 days of in-person training, office hours, collaborative hacking. So beginning and advanced Elixir, OTP, deployment, and more. So if you're interested in any of that, come talk to us at our table, or if you happen to see any of us here, there's 4 of us. And then some other Lonestar activities. We're doing a lunch episode here today with the Elixir Wizards and a bunch of the speakers, so check that out at I think 12:30. Happy hours tonight. Again, tomorrow we're doing a collaboration with the Elixir Outlaws, so we're doing Cowboys and Wizards at breakfast. And then find us at our booth. We've got some swag, lots of cat stickers, so most of what's on this laptop is here. Thanks.